And um, okay, so we'll look at the supplementary exam by 2015. So this is question 5. You are given an exponential function, right? And you're also given a point. This point t there, it lies on f. So the function is f. So the first question is to calculate the value of a. So they already told you that a is greater than 1. It also means that it's positive. Right, so for me to find a, I can use t as substitution, right? Using t. So the value of y, it's 9. So equals a exponent x. I have 9, and the value of a is equal to 2. So I can square both sides. Eliminate the 2, so it's plus minus, plus minus. So I can therefore conclude that the value of a it's equal to a positive 3 because they told me that a is greater than 1, cannot be negative. So getting to the second question. Determine the equation of g if g is equal to f at negative x. So I know that f at x is equal to 3 exponent x. Now, f at negative x is going to be equal to 3 exponent negative x, right? So there's some things that I want to explain here. So you have, therefore, g of x is equal to 1 over 3 exponent x. Let's break down a few things here. So yeah, this thing here, it's a reflection. That's a reflection. So they can ask you this question in different ways. They can say G is a reflection along the vertical axis. Or they can say along what? The y-axis. Remember with reflection, spoke about it in the previous videos. Reflection along the y-axis, x becomes a different sign. So that's what happened here. And then this is from the laws of exponents, right? Where you had a exponent negative 1 being equal to 1 over a exponent 1. A exponent negative x equals to 1 over a exponent x, which is the same thing as 1 over a exponent x from the laws of exponents. Good. Now let's get to the third question. Third question. Determine the values of x for which the inverse is greater than 2. Okay, good. 2. Look at the marks. I don't think you need to find the formula here, right? So look at the value of 2. Look at t, there's 2. But on t, you have 2 as the value of x, then 9 is the value of y. So I have x, then I have y here. Also can be represented by f of x, right? So if I look at the inverse, remember, x becomes y and y becomes x, right? Just inverse, right? X becomes y, and then y becomes x in coordinates. So this is going to be 9. This is going to be x. So x, which is 2. Those are the coordinates for t in the inverse. So this is x, then this is y. This is the inverse of f. Right. So if I'm looking for values of y greater than 2, right? This is 2. Values of y greater than 2. I'm looking for what? The x value. What is the x value where f is equal to 2? The x value is 9. 9 because of the inverse. Because of the inverse. So to answer my question here, I'm going to say x must be greater or equal to 9. Because that's the point there. And the fourth question is is f a function or the inverse of f a function? Explain your answer. Well, if I look at the inverse is going to be shaped in this way. That's my inverse, right? So the inverse of a exponential, it's a function, right? So I'm gonna say yes, it's a function, right? It's a 1 to 1 relation. That is why 1-to-1 relation for every value of x. One x value is related to only one y value. So same thing with the inverse. One x value is going to be represented with one y value.